Okay, to get this show started, can we have a word of the day? Anyone?
Oh, pizza. Yeah.
Okay, that's it. Appropriate. Tuesday, it's pizza.
I didn't see the word from last week. Was it posted? No?
Not sure. I lost track. There was maybe one of the days because we weren't able to stream on one of the days. Okay.
See how each one of those cross at least once. The Y. This is just a vertical. So it never touches. This one does because it crosses the Y. But not this one. So that's why this one is and this one is. It says that they is the even if it follows the X, it's got
So that's how you, when it gives you the equation,
if it crosses three, it's out. And if it doesn't cross at all, it's out. As long as it crosses once, it's in.
Review for test 2 original. This is, there's nothing here.
That's how I see it. But they told you no?
We use this one. Okay, so, yes. Bigger, it's kind of, let's see, how do I get rid of that thing here? Oh, right here. Then, try to make it a little bit bigger. There we go. Okay. So work through it. If we need more room, we'll move it off to the side to deal with each question. I tried to save paper, so I didn't make room in between them necessarily to do it all on the form. The test will have some room so you can work with, but it's also only going to be 15 questions, and it'll be multiple choice. Okay, so is that big enough? Can you see that? Sort of. Well, I guess you got it in front of you too. So
it's not 25 questions, it's 15.
It's 25 questions. I'm in the wrong side. See, I get my other class was 15. This one is, you're right, it's 20. Thank you. It is 25. But they take 4 tests that are 15. We take 3 tests that are 25. The good thing with the 25 is you can actually miss more and still get a passing grade on it, right? 15, you can only miss like 4 to still get 70%. 25, you can miss whatever that math comes out to be. So I don't like to do too much math. Okay. Okay, so we are live streaming, that's good, and recording, so you'll be able to go back and review this. And did I hear you correctly that you just like to kind of start from the beginning and go through it? And I'll try to kind of move forward with enough explanation, and if it needs more, please chime in. If I'm boring you, please let me know. There's lots of pizza here still, and should have got some popcorn too, but okay. So let's go ahead and we'll go with, how about a dark green to start off. So the amount of garbage G produced by a city with a population P, a lot of words, is given by G equals F of P. So what is P? G is population. So the input is population. The output is what? Amount of garbage. Okay. Measured in tons per week. P is measured in thousands of people. Okay, so we've got the thing. So first of all, we've got the town of Tola has a population of 40,000 and produces 13 tons of garbage each week. Express this information in terms of the function. So this function is going to be f of something equals something. Which one's the input? Population. So what do we put inside this parentheses?
40,000.
Good, 40. Why don't we put 40,000?
It's measured in thousands.
It's measured in thousands. So we, again, yeah. If you put 40, that'd be, I guess, okay, but right. So we're putting in just 40 because that's 40,000 people. It's a way of shortening. And then the output is always what? In tons per week. So 13 tons of garbage each week. So would it be appropriate that the output is 13? Does that make sense?
Yep.
And that's all there is
Could
to
it
it.
be the other way? Could it be 13 equals F?
Oh, yeah,
40?
yes, you could reverse this, like, yeah, it could be 13 equals f of 40. Exactly. Both are the same thing. Just the 40 has to be in the parentheses because that's the input. 13 has to be outside because that's the output. Did I emphasize those out and in enough? So, input is in, output is out. Question?
Yeah, I always get, when I was looking at it, I get confused by the F. So I was like, okay, what are you asking me?
F is just a general, it's sort of a name for the function. It could have been G, maybe G of X would have been better for G, for garbage.
Okay.
Yeah, I think, this
It
would
does
have,
say G equals
yeah,
F.
so I think it would have been, we really don't need that F. We could have gone G of P equals garbage.
Yeah, that's what I get caught up on.
Yeah.
I get caught up on.
It's the notion, yeah, the notation. So that's it's sort of a language part or a grammar part. So yeah, we could call it, they do this. They give a letter and then it's equal to this function notation. And they use the F because F for function. So it's just, yeah. So just, I am with you too. It's kind of, and so here, what does the 5 represent?
5,000 people.
How do we know it's 5,000 people?
Because it's the P
It's in the parentheses, so that's where the P is. So this is anything in the parentheses is going to be population. That's population. So it has to be 5, and it's measured in thousands, right? So then what is the 2?
tons.
It's tons of garbage because it's an outside, it's an output. Two tons of garbage.
Now, should you say it that way? Should you say 5,000?
People. Yeah.
Okay.
Produce.
I just said population.
And then you need to say the 2 tons of garbage.
Yeah. And again, remember, on the test, you're going to just have to choose the right answer. So how you actually say it, you're just choosing the right one. So the one that says 5,000 people would be correct. 5,000 people produce 2,000 tons of garbage per week. make sense? Questions? So what this is testing is just, do you understand the notation of f of input equals output? And then from the reading, being able to decide what is input, what is output. And it'll probably, like the next one, will also be the same type of question. So why don't we take a look at that? H of t be the height above the ground in feet. So h sort of is the function. So this is where the h makes a little bit. That's the height above the ground of some rocket that was blasted off, and so it's t seconds. So the input is time, t for time. So explain the meaning of each statement. So again, in the statement is we have an input and we have an output. What does the input mean? Time in seconds. So that one means 1 second. 1 second after launch, actually, right? So this
So
is
do you have to write that 1 second after launch?
1 second is probably gonna, or yeah, 1 second after launch,
Okay.
because it's t seconds after launching. So yeah, you get it right here.
Okay.
Because time has to have a context, right? When does it start? 1 second after what? Yeah, so after the launch. And then what does a 200 tell us?
The feet.
It tells us feet above ground. Feet above ground. So it's 200 feet above ground. And you'll always be safe if you just kind of, whenever you read up here, you just sort of copy and paste type thing. If it says height above ground, just put feet above ground. Sometimes they'll say feet above sea level, which is not necessarily ground, right? Because sea level is a different, yes.
How do you know that? How do you determine, I guess, which one's the input, which one's the output?
From the parentheses. So anything inside the parentheses is going to be your input. And so they give you up here that t is the one that's going to be the input.
Oh, okay.
So yeah, so up in here, they'll tell you. And then when they tell you what t is, they'll tell you what the other one is. So it's usually the input's easiest to spot. It's the one in the parentheses. It'll have a single letter, usually a small case one. You figure out what that's left, and then the whole symbol itself, this h of t, is the output, and that's the other variable. Okay, so look for, and again, I look for the t is right here, and it tells me it's seconds. That's my input because it's in the parentheses. So this really is, t equals 1. This is t equals 2. And after 2 seconds, it's how high?
350 feet.
Okay, so 2 seconds after launch, 350 feet high. Okay, and again, on this thing, you can kind of be sloppy and not really, because again, on the test, it'll be multiple choice. You just have to choose the right one. But as long as, but just, say it. Doesn't have to write it, but as long as you understand it. Okay, and at a minimum, put the units, 2 seconds. It's not 2 hours, it's 2 seconds. It's not 350 meters, 350 feet. So, and then we can understand what we're talking about. So far, so good? Okay, so let's, it's kind of a mess. Why should we take a picture, right? Guess I'll save it. Then we'll talk about this one, but I'll do it with the line, yeah. So for these ones, select all of the graphs which represent y as a function of x. When we have a graph, how do we tell if something's a function or not? There's a test that we sort of apply.
That you can, maybe you'll draw a straight line and it only goes through one time.
Good. So a straight vertical line, let's see, I'll try to see. Yeah, so every vertical line that you draw And again, you could draw multiple ones. We'll cross it only once. So does every vertical line, and I'm not drawing all of them, I've drawn 3. Can you see that every vertical line will cross this only one time? So what that's saying is like this input here has one output. That's what makes a function. Each input has one output. So would you say A is a function or not a function?
Yes.
So say, how about the next one? Yes. So, because now it's a little questionable, like on here, what's really happening. But this is getting just so steep. These, we'll just cross one time, and again, you just draw all these vertical lines. So that's a yes. I'll come back to that. How about this one?
No.
We'll draw one. Just this first one. We could draw many of them, but how many times does this line cross? 1, 2, 3. And this doesn't have anything to do with crossing the axes necessarily, although the y-axis you could see it crosses 3 times. So we could have just used that vertical line. So you're right. This is, we got a yes here for this one, but a definite no here. This is not a function. It fails the vertical line test. How about D? We'll just do some quick vertical lines. We're going to be okay. Yeah, so yes. So it's things like circles or things that sort of double back on themselves. So this is a yes, right? Lines going straight, but this is a definite no. You know, this line crosses in 2 places. Circles are not functions. Okay. If it's not a function, what do we do with it in this class? Don't pay attention to it. Ignore them. So that's really all we do. And even in your one, if you go on to 121, same thing. You'll ignore them. We don't do non-functions. We are discriminating. What happened?
That's your word of the day.
It's my word of the day. That's weird. Didn't realize, okay, I pushed the wrong button, I guess. There we go. Now it's cleared off. Go back. Oh, we have to go all the way back here. That's going to look weird for the notes, but that's okay. Go there. Okay. So let's keep going. The next one's kind of similar, so we'll maybe go a little bit quicker, but just it's the same concept, vertical line test. Oops. There we go. Okay. So how about A?
Yes.
It is vertical, all these vertical lines, it will pass, it's a function. How about this one?
Yes.
Yes, it doesn't double back on itself, it's everywhere it's crossing only once. Each input has only one output. How about this one?
No.
Nope, there's a good one right there, crossed twice, so that's a no. How about the circle?
No.
So we can spot these, usually non-functions you can spot pretty easily. Okay, this one?
Yes.
Yes. My lines are not quite vertical, but you get the picture, I hope. How about this one? Is a vertical line a function?
No.
Because you draw a vertical line on top of a vertical line, and it doesn't pass. It's one place. So a vertical line is not a function. And that's why we're able to use it to find non-functions. It takes a non-function to find a non-function. Right? Think of some saying. It takes a liar to know a liar, I guess, or I don't know. There's something else like that. It takes something to know something. Okay. Good. So that's that one. We're making good progress. And again, we've got plenty of time because we got all day Wednesday as well. And again, go back on the ones that maybe you're picking up and understanding now. Maybe take a look at some of the homework ones. But again, I'll count this for all the homework as well if you want to. Just make sure you're prepared. As long as you do well on the test, you prepare yourself anyway. I'm not so concerned about how much homework is or isn't done, as long as you're doing well. If you don't do well on the test and you didn't do any homework, then that's a sign that, well, maybe you should go back and do the homework. And then we'll have you retest again, okay? But if you are doing it, we'll make it all work, okay? So what's going on here? Select all of the following tables which represent a function, y a function of x. What does a y a function of x mean? It means each input has how many outputs?
1.
That's all that means. So when you see a function of, all it's asking, does each input have only one output? It's all these questions, okay? So as a table, the first thing we look at, if the inputs are all different, do we even, is that going to be a function?
Yes.
It's guaranteed. So 5, 10, and 15, there is no repeated input, so each input has only one output. Don't get, well, yeah, this, and they're all separate anyway. So yeah, this one's a yes. Each input has one output. That's all this question is asking. It's just so wordy.
That's what I was getting caught up on.
Yeah.
I was like, that's why it's-
That's all of these, yeah, all of these questions and all that, even that graphing picture. Each input has one output. Okay, 5, 10, 15. It's a function, right? None of the x's are repeated. Some people get thrown off because they start looking at the y's, but there is no rule that says that each output can only have one input. No, it's only the inputs are restricted. And since each input is listed once, each one of them has only one output. They can share them, but okay, so this is a yes. Okay. How about this one? We've got 5, 10, 10. We've got a repeated output. Now, does that automatically make it not a function? Not automatically. We got to check, do they have the same, because if they have the same output, it would be okay. But do they have the same output?
No.
No. So this is like you ask the question, what is 10? Who's 10's partner? And you get two different answers. So the other way I like to think of a function, each question, the inputs the question, has the same answer. But the question 10 has two different answers. Does that make sense? So this is not a function. So when you have a repeated input and different outputs, that's the thing that's not a function. But there'll be one in here where it will be repeated, I think. Okay, so that's, and again, just practice. 2, 6, 13, all the inputs are different. Automatically, we don't even look at the outputs. This is a yes. 2, 6, 6, we got a repeated input. What about the outputs?
Different.
They're different, so this is a no. Okay. 2, 6, 13, they're different, so we don't even look at the outputs. We see that all the inputs are different. It's guaranteed to be a function. This is the same thing, except the numbers are now going side by side. So the input comes to the left. So this is input here and output here. It's probably not a good idea. It's supposed to erase. It didn't erase. This will erase. Okay. So we'll go over this real quick again. 0, 3, 4, 8, 3. Is there a repeated input?
Yes.
Yes. But does this make it not a function? 3 is 1. But 3, it's got the same. It just, it repeated the whole point, but it's still, it's got the same partner. Okay. So each input still only has one output. Okay. So this actually is a function. This is the one that gets tricky. Okay. 3 goes to 1, but 3 still goes to 1. So you ask the question, what is 3? 3 goes to 1. It's the same answer. Okay. Negative 1, 2, 5, 8, 12. All different, right? So it's got to be good. We don't even look at the outputs. 0, 3, 3. Okay, we got a repeated out or input. What's different outputs? So this is a no. Oops. I see. You ever say this yes and then no, or you know, one of those things? What did I say? It says a no. Okay, no is no. Yeah. Ask mom. She says no. Dad says yes. Something like that. Negative 1, 1, 4, 9, 12. All different. It's definitely a function, right? We don't even have to look at the outputs. So this, you know, this is the sort of easy part. Again, they give us lots of practice. Negative 4, 3, 6, 9, 12.
Yes.
It's a yes. All of them are different. Negative 5. Okay, here we've got a repeated 2 and 2. They have different outputs. That makes it not a function. Okay, this is the no. Negative 1, 1, 5, 9. Oh, here's a 1, repeating between a 1 and a 1. But they have the same output, so this remains a function. Okay. -1, 3, 5, 8, 4, all different inputs. We don't even care about the outputs. Okay, this is a yes. So just kind of train yourself. Look for the inputs first. If there's a repeating input, that's what you look for. And then compare it. If they've got different outputs, that's not a function. If repeated inputs have the same output, we're still good. And then just don't, so yeah, that's the key, is just train yourself to focus on the important stuff. Don't, because otherwise you start looking at the outputs, you'll get distracted. Because again, a function really is, the rule doesn't say anything about the outputs. So far so good? You in good shape? So we got through 8 of them.
Yeah.
That's almost a third of it, and that's pretty straightforward. And then I guess 15 and 16 do the following. Evaluate f of 3 and then solve f of x equals 1. Okay, so f of 3, how do we find f of 3? Let me see if I don't know if I can move that up, but I can make it bigger. Well, I think I need to go like this.
So it's 3, 0, because y 0
Oops.
is fx.
Yeah, it's all video, so it's recorded. See if I can make it bigger. And then somehow, where am I? Okay. Okay, so 15. Let's come back here. If I write with a white pen on a white paper, I don't think we're going to see much, right?
Here.
So f of 3, where do we go?
So this one.
We go here. Do we go up or do we go down?
Go up.
Up and locate that point. So the answer for 15, f of 3, x is the input, is equal to 1. The y value, that's what we're looking for. Let's do the same thing for 16. We go to the 3, so this is the 3 inside, means it's input, it means it's an x value. We go down till we hit the y value, and what is the y value? -1. So for this one, f of 3 equals -1. So far so good. So it's just looking it up on the graph. When we've got the input, we go to the x, and we look up or down until we hit the graph. And then we read the y value. That's what that says to do.
Okay.
Okay. So I'm just going to put f of 3 equals y. This one, the B question says f of x equals 1. So 1 here is what? An x. It's a y value. So we go on to the graph. So for 15, we go to the graph. Let me change colors. How about blue? The graph, how about violet? Okay, so I'm going to do this one in violet. So looking for that. So here the y is 1. And watch, where do I go to hit the graph? I go each of the ways. So I go here, here, and here. This one actually has 3 answers. Y is equal to 1 when x is equal to -2, +1, and as we found out here, also 3. There's 3 answers to that question, which is okay because an output can have multiple inputs, but each input has only one output. Does that make sense? Okay, so for this particular graph, there are 3 outputs that have 1 as the answer, that are a y value of 1, and we listed those 3 different inputs that match up with it. Sorry, I might have said that wrong. 3 places, 3 points that have a y value of 1 on the graph, and we list each of their x values. Yes?
Aren't you supposed to do those points on the other graph?
Yes, and on the other graph too. So when we come here, again, the same question, solve for f of x equals 1. So the y value is 1. So we identify the places on the graph that have a y value of 1, and then we record their x values. So this first one, x equals 0. X equals 2. So I'm just going to list it this way. We could list them x equals 0, x equals 2, and x equals 4. So there's 3 answers for that one as well. Okay, but it's just a lookup, but it's looking it up sort of the other way. You find the y first, and then you find the x's that go with that y. For this first one, where we've given the input, we go to the x value, and then we look for the y. And we're guaranteed when we're given the input, there will only be one output, because if there's not, it's not a function, right? The problem is when we got the output, it's possible that there could be multiple inputs that have that same one. And that's what we found on these. Each of these graphs have 3 different outputs, or sorry, 3 different inputs for the output of 1.
Now, for x equals -2, 1, and 3, would you put brackets on those, or no?
Yeah, I would just.
I mean, is that going to be on the test that way so that you know if it's both ways, which is the correct way? Or are they both correct?
They're both correct. This is correct. They probably will list it as x equals -2, x equals 1, and x equals 3. But yeah, the formatting is not really all that much of an issue. We don't get it that much. So
it could be the correct answer, x equals -2, x equals 1, x equals 3.
Right.
Okay.
But it'll be clear. And I think what will be different is they don't do a formatting change. They just do different numbers. So you're looking for the answer that has a number, -2, 1, and 3. There might be one that just says x equals -2. That's not an, this is a better answer because there's actually 3 places. So far, so good. So we're definitely halfway through because there's 31 questions and we got 16. Okay, so we're at least halfway through. We're not even halfway through class yet, are we? Well, I guess we are. Clean page. How's it going? I guess I had more room. I didn't realize I had. Oops. So 17, same type of deal that's going on, except now we have a table instead of a graph, right?
I wasn't sure which direction it was going.
So this 8, what is this 8? It's input. Input's always on the top, so we go to the input of 8 and look up the output, 75. The second question, the B, again, notice one is evaluate, the other is solve. So solve is different than evaluate. Where do we go? What does a 7 represent?
Output.
It's an output. So we're looking on the bottom. There's a 7 as an output. We look up to find the input. So we found that x equals 2. And it could be written, you could write it f of 2 equals 7. Or it could be just x equals 2. I bet you if they're going to put on the test, they would do this. They would just put x equals 2 because that's what solve looks like. Okay, so it's a lookup, but it's looking up in a different order. Is that okay? And I would expect, one like that as well. Questions? Doing okay? Okay. Oh, geez. It's a lot of work. We'll do 1 or 2 of these, and it's just. Is there an answer key to this? No. I'll work them all and I'll make an answer key, but it's kind of more, make sure you know how to, remember it's all about the process. So what are we doing with each of these?
Replacing X for the
Good, because they're giving us inputs, right? All of these are inputs. So again, it's probably tedious. These ones are going to be the worst, so we'll do a little bit of each. And I think we'll bring up the one that you came up with, because there's when we've got the negatives, there's some things that you might be getting wrong here, and I'll just we'll highlight it. So this evaluate, what we do is we take each function. So let's say f of negative 2 is going to be equal to 4 minus 2, and then replace the x by a big parentheses, and what goes in there? Negative 2. Okay, so now it's just calculate. Negative 2 times negative 2 is a positive 4, so we end up with 4 plus 4, which ends up being 8. And that's our final answer. And then you would do that for each of them, and you get a little different answers, right, for each one. So it's just repeatedly plugging in the different values for x.
Okay, so would I would just go on to use the next number, the next set of numbers?
Right,
The
so-
-1?
Yeah, each one, and then they'd want you to go, f of negative 1 is equal to 4 minus 2 times negative 1. And you might be able to just look at some of these, right? So, again, for each of these, they want you to use all of these for each of these. So each of these questions should have 1, 2, 3, 4, 5 answers. There's not a lot of room to do it there, but
Wait, you said each question?
each question, so 18 should have 5 different answers. You should have f of negative 2, f of negative 1, f of 0, f of 1, and f of 2. That's what they're asking you to do. The test won't ask you to do it that many times, but
Okay,
they figure it's repetition, and maybe you want to stop. I'm with you. I feel you. I don't want to do 5 times.
Okay, that's what I was getting at.
Yeah. So then this one will be 4, negative 2 times negative 1. That's going to be a positive 3. So that would be equal to 7. F of negative 1. There's just not enough room in here, and it's just tedious. And you might see the pattern. They're going up by 1. So yes, it's 8, 7. This one will be 6, 5, and 4. So you know. What's that?
20, 21.
20 and 21. Those are the ones I want to skip. So, but no, we'll do this. Okay. So.
Let's not.
So 18 and 19 both seem reasonable. We'll do 20, and 21 is pretty much the same thing. So what you want to do is we're taking a function value, and again, we're doing each of these 5. So f of negative 2. And again, what we do is we take the function, rewrite it, replace the x with a nice parentheses with something to plug in. Oops. Instead of the x, I want to rewrite this. So this should be 7, big parentheses. What goes in the parentheses? The negative 2. And maybe I'll change colors just so. Okay. And so it's going to be negative 2 squared. Now let me talk about this one just a little bit. I think I can make it happen with this calculator. Make it into a scientific calculator. So if, let's see if I can do this. If I had, say, take 2 and I'll make it negative, then I'm going to square it. Let's see, let's do this x to the y. And my exponent is 2. Watch what happens when I do it this way. Oh, shoot, it does. This calculator doesn't quite do it. Yeah, it's, but here's the thing that happens. I'll talk a little bit. So, some of you see this negative 2 squared. If you didn't put the parentheses and you do negative 2 squared, some calculators, most calculators should take, doing order of operations, it should square the 2, which gives you 4, and then puts a negative on it, so it gives you the answer of negative 4. However, when you are plugging in for a value of x, remember these parentheses here, if you do it this way, the calculator is supposed to see, well, I'm taking negative 2 and I'm squaring it. That's negative 2 times negative 2. Which is equal to a positive 4. And that's the correct answer. Okay, so it should be positive 4. But, so just be careful. This calculator did the right calculation even though I didn't have, but I think because I used this thing, you know, so it kind of put the parentheses for me. But a lot of them, if you don't put the parentheses, it gives you the negative answer, and you think, well, the calculator gave me this answer, right? It must be right. Calculators are always right. Well, calculators do exactly what you tell them to do most of the time, and so it was how you told it.
So the x squared is not the same as the xv on your calculator?
It's
Or
x
xy?
x to the y. It might do different. Let's see if it. Let me clear it out. And again, that's the other thing is with calculators, they're programs actually, so you don't always know exactly if it's doing things correctly or not. Also the x squared. So this one is it's figuring it's taking that number and squaring it.
Because that's the one I use
Mm-hmm.
when I'm doing it, so I wanted to make sure that when I'm doing it, that it's...
Yeah, but on your calculator it might be different. If you're using that exact same app, it probably will behave this way,
It's
and
on
you're
my
fine.
phone, so my phone does...
Yeah, so
that.
it's an Apple one, so it probably, as long as you're getting, yeah. What I'm trying to say is, if you got negative 2 squared like this is supposed to be positive 4. So as long as you know, then you're able to manage what the calculator, if it's the calculator's really speaking the same language you're intending it to speak. So yes. Okay. But just be careful, because if you put it in this, many calculators will return the answer of negative 4, which is not correct, because
Right.
it's
Yeah, I do put it in parentheses and then square it out.
good. Then you're always going to be fine. Okay. So that's going to be 4 times 8. So I guess we could go ahead and go 8 times positive 4, right? Negative 2 times negative 7 will give a plus 14, plus 3. 8 times 4 is 32, plus 14, plus 3. And again, you could also enter this all in a calculator and it'll do it all for you. But the correct answer should be what? That's about 46 plus 3, 49.
And then what about the negative 2 at front? F.
That's the answer. So the final answer is f of negative 2 equals 49. Okay. We do not divide by negative 2 because that's not with those. That parentheses is just a function notation. It's just sort of the way we write it, so that the input is on the same part of the answer with the output. And again, you do it 5 times with all the numbers, so you'll get 5 different answers. So it's an opportunity to do a lot of practice. 21's the same thing, which is different numbers, but it would have the same thing. And I guarantee you there'll be one on the test that has an x squared. And they will probably be having you put in a negative number because that's what they're wanting to test. That's the hard. If it's not negative, it's pretty easy to go straight forward. But they're testing you on that. Do you know that when you square a negative number that's being plugged into a variable, that it's going to become a positive? That's kind of important to know. Because that's the one area where we have the calculators have the problems. And students will show me, my calculator said it's negative. But it's because it's following the order of operations. So we good? Sorry, okay. So we'll get this guy out of the way. Looks like we'll probably get all the way through this, and then that way Wednesday we could pick up any last minute things. This will be, again, available to view. Let me just clear all this out, or just get a new page, I guess. And let's move this up. So this is going to be domain range type stuff. And we've got four good examples here. Write the domain and range of each graph as an inequality. I think this first one up here, it says write the domain using inequality notation as well. Okay, so when we're looking at the domain, what are we looking for? The input. So again, where does the graph first start? So coming from the left, would you agree that that's the first?
-1.
Okay, so sort of, I did this before. We draw a box here, and then we keep seeing graph, 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 and where does the graph stop? Here. So I'll try to put it sort of just to the edge here. Now, notice the difference in circles. This one is an open circle. What does that mean? A parentheses, right? So, again, if we had interval notation, which they're not asking for, but it would be a parentheses here at 3, and this one, since it's solid, it would be the square bracket at -5. Okay. But they want inequality notation, so what we do is we just put x in the middle, less than. 3 goes here. This stays just less than, not equal to, right? Because it's an open circle. -5 has a closed circle, so that's going to be equal to 5. So you just put your boundaries on each end, and x is in the middle. Okay, is that okay about domain? So we're looking basically the extreme values for the x values, the left and the right boundary. X is between the two.
Would that one also do y?
The y is when we're looking for the range. So this one we found the domain. And then when we go looking for the range, that's correct. We're going to we're going to go from the bottom, and when you come from the bottom, where do we first hit the graph? It's right here at 0. So again, I'll just kind of draw a line that this is where the range starts. And how far up does it go?
2.
It goes up to 2. This is the end of the graph. This end is included, this is not, but would you agree that 2 is going to be included?
Yes.
Because if it's included on one side, it doesn't matter. So the range is between these two values. So the range is the y. So we write that with y in the middle, less than, and since both sides are included, we put equal to, and what's the bottom?
0.
0. What's the top?
2.
2. Okay, so that's our range. On the test, sometimes they might, you just look, but see they have y's here. They could use f of x, but the output. So the range talking about the output, the domain's talking about the input.
Where did the 0 come from again? I'm
Yeah.
sorry?
0 comes
Zero
from
is
right here.
Is the line
It's the smallest, it's the lowest y value. So notice
Oh, okay.
it doesn't show up. They didn't put a 0 there.
Okay.
But this point, this would be 0, 0. So this,
Okay.
yeah.
I gotcha. Thank you.
So let's kind of talk through this. So on this one, coming from the left, where did we first hit the graph? -3. And again, we could draw the lines. So -3, first hit the graph, and it's included because it's a solid dot. We keep going, and then where does the graph stop? At 2. It's not included because it's got an open circle this way. So what we write is x is between these two, less than or equal, starting at -3 is where the graph starts, and it ends at +2, and it's just a less than, no equal to. Okay, and those inequalities always go the same direction because we're going from smallest to largest. Okay, so if you go from left to right, you always get your numbers in the right order, and then for the ranges, go from the bottom to the top, and you'll always have your numbers in the right order. Well, this one's a little tricky. So this one, I imagine there'll be one like this on the test. So let's switch over to red again. So for the range, where do I first hit from the coming from the bottom? -5. This is the first place right here. So this is sort of like what we would think of the bottom of the function. And then where's the top of the function?
4.
Not here, just because there's a point there doesn't mean we stop. We go all the way to the very top. And is 4 included or not included?
Yes.
It's included because you said before.
Good.
It would be.
Yeah, the only way it could not be included is if there was an open circle there. And there's not an open circle, so we say it must go through there. It must be a solid circle. Even there is no circle, but there's no point, no specified point. So again, the y is what's in the middle, and we always just kind of go like this. They're both going to be included, so we put equals to on both. The bottom is at -5. The top is at +4. So there's our range. Okay, bottom to top. Range is always bottom to top. Lowest y value to the highest y value. Think of it those ways. Yeah, and I like to turn it sideways. It's sometimes easier just because then you're doing the domain and the range almost the same way. So if you can, yeah, just think that if you turned it sideways, range would be exactly the same. So where does it start? Where does it end? Is that good? Please don't be shy about the pizza too. There's still plenty of pizza. So go ahead. Okay. Down here, they're just straight lines, or here. So how about this one? Where does the domain start?
2.
Where does it end?
8.
Okay, so which is 2 included? No, it's an open circle. 8 is. So domain is going to be 2 to 8. We put the x in the middle, and we put our little inequality guys like that. The 8's included, but the 2 is not. Okay? That okay for domain? And when you're using inequality, you use the letters x or y, so that's you're able to tell domain and range. And we come over here for the range. So I'm coming up, where's the first y value? What's the lowest y value? 6. What's the highest y value? 8. So again, I go from bottom to top, so it's going to go from 6 to 8. Y will be in the middle. We get our inequalities, and then we come back. Is 6 included? Yeah, it's a nice dark circle. Is 8 included?
No.
No, it's an open circle, so we leave it. And that's range, bottom to top. Okay, and again, you could draw the lines if that's helpful to you. You're basically boxing it in. Does that make sense?
Where did the 6 coming from?
6 came from the first y value happened at 6. The bottom, the lowest.
Oh, I was looking at the other one.
Okay. Yeah, good. Lowest y value 6, the highest is 8. And you could mix it up to, you could do the range first if you wanted to, but we'll try to keep consistent. So maybe I should have stuck with the same colors too, but do it this way. So on 25, where's the first x value? Here it is.
Oh,
4.
It's 4.
And then I keep going. Where's the last x value? There it is at 8. So the domain goes from 4 to 8 with x in the middle, less than. 4 is included, right? Because it's a solid point, so I put the little equals to. But 8 is not included because it's an open circle. It's a hole. So 8 is not included, so that is the domain. What's the range?
2 to 8.
Good. We come from the bottom, we see the 2. We go all the way to the top, we see that's going to happen at 8. So it's going to go from 2 to 8 with y in the middle, less than, like that. Is the 2 included? No, it's an open circle, so we leave it alone. 8 is included, so we'll go like that. Okay, so all domain, you read the graph from left to right, the smallest x to the largest x. For range, you read from bottom to top, the smallest y to the highest y. That's all it is. We're talking graphs. But there's two separate things going on, and you really have to, and a lot of times with math, that's what you got to do, is separate things. I found one of my biggest problems is I tend to add when I'm supposed to multiply and multiply when I'm supposed to add. Because a lot of problems, you're almost doing them simultaneously, right? It's slowing down and doing one thing at a time. That's what I found works for me. Okay, so that'll be on the thing. I guess we have a few more minutes. You want to just keep chugging away?
Yeah, tell me if you will.
Or should I give you a reason to come back? You always have a reason to come back, right? So.
Yeah, keep the pizza till Wednesday.
Pizza, yeah, we'll keep the pizza till Wednesday. We'll put it on ice till Wednesday. That's a good one. Okay. So we'll see if we can squeeze these guys in here. I think we'll be okay. Let's go with the blue. So we've got an equation. Find the horizontal and vertical intercepts, two things. So if we want the horizontal intercept, what does that mean?
That's the x. Oh, that's fine. See, that's
Y
what I
equals
get
0.
at.
Vertical intercepts, that's where x equals 0. I was running into a previous student of mine today who's in a Math 150 now, and she was actually tutoring someone else in one of these buildings as I just came onto campus. I stopped by, said hello, and she goes, "Oh, your perfect timing. We need to find a horizontal intercept. How do we do it?" And I says, "What is y equal to?" She said, 0. She still remembered. And I said, yes. And then she says, "Oh, now I know." So yes, all this means is we've got the horizontal, we're going to put in 0 for y and solve for x. To get the vertical, we put in 0 for x and solve for y. Okay, so for the horizontal, we rewrite this as y is 0 equals 2x minus 1. Solve for x. Okay, how do we solve for x? What's our first step? Would you add 1 to both sides? So this cancels. So we get 1 equals 2x. Should give more room here, but. And then what do we do? Divide by 2, exactly. So then we get x equals 1/2, or 1/2 equals x. But if we're going to write it as an intercept, which is a point, how would we write this point? We would write x is 1/2. What is y? 0. So that's an x. That's a horizontal intercept. You'll find the vertical intercepts are a little bit easier. Let's change those to green. Because what we do is we take the same equation, but we plug in 0 for x, so this is more of a evaluate. We're going to have y equals 2 times 0 minus 1. Y equals 0 minus 1, right? Because 2 times 0 is 0. 0 minus 1, it's -1. But to write it as an intercept is a point which needs an x and a y coordinate. So how do we write this?
0.
0, comma, -1. That's the vertical intercept. If you remember this, this will take you the rest of the way through your mathematics. But you have to remember it. The vertical x is 0. The horizontal, we didn't go up or down, so y is 0. It takes a little bit of thinking, but just remember 0 is involved with both of them, and you just got to get them in the right place. Otherwise, you're solving for the other one. Okay. And if you want, you could kind of go ahead and say, I got them both, so now which one is which one? 1/2, 0. What's that? Let's go over 1/2 and then don't go, oh, that's a horizontal intercept, right? And then 0, -1, 0, and then come down 1. So that's got to be the vertical. So sometimes go ahead and put them on a graph, and that will help emphasize what it is. And remember, I can't remember if I told this class or the last class, but your brain needs to see pictures. I think I was talking about that in my afternoon class. It helps your brain if you look at a picture, because your brain doesn't think in English. It doesn't think in any, even if you've got a second language, Spanish, whatever your first language is, your brain actually doesn't think in those languages. Your brain thinks in the language of thought. And the language of thought is pictures. We are visual people. That's how we survived all these thousands and hundreds of thousands of years, is we learned how to process visual clues. And we think visually. We really do. We've gotten these higher level languages that we communicate with each other, but our brain still works on pictures. So, these words, vertical and horizontal, the brain doesn't pick that up, but you draw a picture of a vertical graph and you put those things, that's what the brain can understand. And it'll thank you. Your brain will thank you someday. Say, thanks for not making things so hard on me. Right? You'll thank your brain for helping it, right? Okay, same thing here, right? All of these, look how many questions. This is really literally from lesson 6. So again, the first thing for the horizontal, let's change colors. Let's go back to blue. Horizontal, we're going to put 0 in for what? Y. So again, we go 0 equals 1/2 x minus 4. Solve for x. Right? So what do we do first? Add the 4. So that this cancels, leaving us with 4 is equal to 1/2 x. And then what do we do? We get rid of the 1/2.
Divide
By what? The half. You could divide by a half or multiply by 2. It has the same result. 1/2 divided by 1/2 is 1. 1/2 times 2. You'll see the 2 cancels with the 2. And 2 times 4 is 8. So x is equal to 8. And to get to do a horizontal, we put it as an ordered pair, 8, 0. And again, it'd be nice if there's a little bit more room. This is kind of, and I might redo this video with all the extra time I have in my life, right? I always think that sometimes. If I could get things done as fast as I could think about them, right? It would be done like that, and I'd be done. But it takes 2 hours to make a good video, So it takes 2 hours to do that. Yeah, just the time just goes. But does that make sense? You just put in 0 for y and then solve for x. We've been doing this, right? Okay. So 2 times 1/2, that cancels that. What do we do to get the vertical? Replace x with 0. So when we get the vertical, we take that same equation, but instead of x, we put in 0 for that. And you'll see that's always 0, we multiply 1/2 by 0, it's 0, right? So y equals -4. It's just so much smoother. In fact, you might not even need to write it down. You just see, well, if I put, you know, I like to just cover it up. Y is -4. That's how I plug in 0 for x. That's the quick one. Plug in 0 for y, you gotta solve everything. So finding the horizontal intercept is always going to be more work. Vertical intercepts are usually fairly easy. A lot of times vertical intercepts, they're right there in the equation. You just have to cover up the right part, the part that goes away. In fact, yeah, for those of you who take 121, we look at like 5 different types of equations. You can always find the vertical just by really covering up the right part of the equation. It's right there. So it's almost like there's no math to do, but the math is because we're plugging in 0 for x. Okay. So again, the vertical is going to be 0, -4. Okay. This one's a little different because it's got x and y on the same side. So this one's actually going to be maybe a little easier. It's just about the same for both of them, right? So to find the horizontal, we plug in 0 for y. So we have 3x plus 2 times 0 equals 8. 2 times 0 is 0, right? So we end up with 3x equals 8. And then how do we solve for x? Divide both sides by 3. So x equals 8/3. Doesn't reduce, that's a perfectly fine answer. You could also take 8 divided by 3, turn it to a decimal if you'd like, but 8/3 is perfectly fine. How do we find the vertical intercept? We put 0 in for x. So then I'm going to take 3 times 0 plus 2y equals 8. 3 times 0, 0. So that's gone. So we just have 2y equals 8. And to get y by itself, divide by 2. So divide this side by 2, that cancels. Divide this side by 2, leaving us y. 8 divided by 2 is 4. And again, the ordered pair will always have x is 0, y is 4. Oh, word problems. But there, I think it's actually one problem, but 3 questions. These are 3 sub-questions. You have enough energy to keep going? Or you want to just wait till Wednesday? You don't care? You want to? How many want to see this? Nobody wants to see it? Good, because I don't want to do it either. I'm tired. Okay, so we'll go for Wednesday. Got to give us something to do. And again, it'll be on the video. So this, we did almost all of them. We keep looking. You want to take something for the road, help yourself. Thank you, guys. It's great. Yes.
Don't delete that.
Okay. I'm just going to turn off the streaming so that